Now we're going to make our bird actually do some flying. We're going to make it launch off like an Angry Bird in Angry Birds and go flying, well, in the opposite direction of the way that we pulled it. So if I pull it straight back, it'll fly straight forward. If I pull it straight down, it'll fly straight upward, and so on. So we're going to need to write a little bit more code to do that. And to do that, we need to open up our bird script. So we'll double click on the bird script here, get it open. And what we want to do, well, there are really two things. First, we want to keep track of our starting position, the spot that we're in, well, when our game starts, just our initial position. And then we want to, when we release the mouse or in our mouse up, launch our bird off towards that starting position. So we'll figure out what that start position is, save it off in what we call a variable or a field. And then on mouse up, we'll just launch our bird towards that position. So to do that, I'm going to first zoom out my bird script. I'm going to hold control and use the mouse wheel and zoom out so you can see the entire thing. And then I'm going to go right up to my start method. Right at the beginning of my start method, I'm going to add in a new line. I'll just hit enter here on line 9 to add in another space, and I'm going to zoom in a little bit before I start typing. What I want to do here is save off my starting position, and I'm going to save that in what we call a variable. In this case, it's going to be a variable that's called a field because it's stored at the class level. Now you're going to see that I'm not going to actually start typing it at the class level. I'm going to start typing it in the start method, and then I'm going to let the editor do some magic and just kind of autocomplete for me or save me time so that I don't have to type as much. Now the name of this variable is just going to be start position. I'm going to name it start position because this is going to be my starting position, and I'm going to prefix it with an underscore. And that's just a naming convention or a habit of mine where if I have a variable that's not going to be specific to a method where it's going to be up here at the class level, I like to do it with an underscore first. So it's going to be underscore start position with a lowercase s and a capital P. And I'm going to start by just assigning it to a value. And what I want to assign it to is our current position. And there are two ways that I could get it. I could either use the transform position. So I could say it equals transform.position. But I don't want to do that because that's a vector 3. And right now we're working in 2D vectors. And I want to cut out that third part of it, the z part. So what I'm going to do instead is get the rigid body 2D's position. So I'll say get component, rigid body 2D. And then I need my open and close parentheses, and then dot position. This will return back a vector 2. If I put my mouse over it, you can see right there in the little tooltip, it says vector 2, rigid body 2D position. That means that that's the return type. And that means that my start position will be a vector 2. Now right now I've got an error saying, well, what does the error message say? The name start position does not exist in the current context. That's because so far I haven't defined my variable. I haven't said, hey, what start position is, or where it is, or what the scope of it is, or anything like that. And you might not know what any of that means. What it really means is that I need to click on this little button here and hit generate field. And it's going to put in some code right here at the beginning of my class. It's going to say private vector2 start position. This is how we define a field in our code. So it's a variable that is saved off for our bird, and it's saved once for every single bird. If I put multiple birds in here, each one of them will save off its own start position in its own start position variable. Now it does start with this private keyword here, and just like with the methods down below where I said we don't need it for our private fields either. So I'm going to double click on it and hit delete twice. All right, now we have our start position saved off or cached. I want to scroll down and get to our mouse up part and do the launching. Make our bird go launching off in the direction towards our start position. So to do that, I first need to get the direction to our start position. And we can do that with a little bit of very simple vector math. We'll need to get our current position and then just do a little bit of subtraction. So I'll say var current position. This is going to be a variable named current position, equals get component, and we'll get the rigid body 2D. Oh, I got to type in the 2D part right there with the open and close parentheses dot position. So this is going to save off our current position, which is a vector 2. I could also type this as vector 2 current position. It's just that I know that it's a vector 2, so I didn't. It doesn't matter either way. Var is just a shortcut for different variables, and it'll let the editor just say, hey, I don't want to type out the name of it, just know that it's a variable and understand what it's going to be by what I'm assigning to it. So since I'm assigning a vector 2 to it, it would be a vector 2. but we can just use vector2 as well. I just wanted to show you that var syntax because sometimes you're going to see it and it might be a little bit confusing. Just know that it's a shorthand for just any old variable. It doesn't mean that it is any old variable. It just means that we're not writing out the name of it. So we've got current position there. Now I said we need to get the direction. To get the direction, we just need to do some subtraction. So say vector2 direction equals, and then we'll use our start position, so underscore start position, minus our current position. Now what this is going to do is subtract our two vectors. It's going to subtract that start position from our current, put it into a direction. And a vector2 is just a vector or a variable that has an x and a y component. So it's really just a x value and a y value that are floating point numbers, just numbers with decimals that could be positive or negative. Essentially what we're seeing right here. Let's go to the bird and just look at a vector. Here's a vector3 where we have x, y, and z. When we access the vector or position from the rigid body 2D component, since it's 2D, it has these two, just not that z value. Now let's look at why we would do that subtraction of the start position minus our current position. Let's say that our start position is right here. In fact, let's move our start position right now to 0 and 0 because I think that that makes it a little bit easier to understand the math here. So our start position's at 0, 0. And imagine we've drug our bird to the left 1 meter. So we go to -1. It's now gone 1 to the left. In fact, here, let's move him even further to the left. Move him -2 to the left. Imagine that's exactly -2. There we go. Now it is exactly -2. So what would the direction be if I did some subtraction here? If I subtract my start position and then my current position. So my start position would be 0 minus -2. Which means that my vector or direction is going to be a 2. So that means that if I move my bird with a vector with a value of 2 on the x, so say that I moved him in that direction just one time, I would do a +2 here. Oops, let's see if I can type that again. Can I get my plus in there? +2, and he would move right over there. Obviously, I don't want him to move that fast every frame, but that is the correct direction. That's the way that he would go. If I moved him to the left and down and did the subtraction, again, you'd see I'd get a positive 1.3 and a positive, 1.27 here for my direction. That would be my vector, the x and y values of it. So that's going to give us the direction and the distance, though, not just the direction, because it's 1.3, and if I drag it off 5 meters to the left, it would be 5 instead of 1.3 or whatever. So we need to add another line to the code that will remove the magnitude or the distance from our vector and make it just what we call a normalized vector, where the total magnitude of it becomes 1. That means if it was only going horizontal, the magnitude would either be -1 or +1. If it was only going vertical, then it would be positive or -1 on the y. And if it was going like at a 45-degree angle, you're going to get a, 0.707 on both of them. And you'll see how those values line up later, I think. But for now, just know that we need to use the normalize method on it. Let's go into the bird script and add that in. So we'll go right below our line 24 where we're assigning our direction. We'll say direction dot normalize. Right here, not normalized, by the way. Normalized returns back the normalized value of it. Normalized will just change our existing vector. Very different the way that they work, although they both give you the same thing. So now we've got a normalized vector. We've got our color getting set back, and what do we need to do? Well, we need to launch our bird off in the direction of our normalized vector, or in this direction. So to do that, we're going to go in here, add in 2 more lines because I want a little bit of spacing, and I'll say get component again, and we'll get the rigid body 2D one more time. And here we're going to add force in that direction. So we'll say add force, and then we give it a vector2, which is a force amount or a force vector. We'll just give it direction. And then I want to multiply this. I want to give this some value that I can set on the bird where I can make this go faster or slower. We're going to start with just multiplying it by a number like 5, though. So I'm going to put star, which is our multiply, and then 5. So this is going to add force in our direction times 5. So whatever direction it is, we'll launch it off at a 5. We'll see if that does anything or if that value is way, way, way too low. Let's add a semicolon at the end, save our code off, and then go into Unity, hit play, and see what happens. All right, so I've got my bird still at 0, 0, 0. I'm going to leave him there for just a moment. We'll click, drag, and release him, and, well, nothing really happened at all. He just kind of sat there. So let's go take another look at the code. Why didn't he go flying? Well, if you remember just a little while ago, let's zoom out. We did set him to kinematic, and he is not going to go flying on his own. So in our code where we launch him, we also need to set him to not kinematic. So I'm going to take this line here on 13 and select the whole thing. Just click and drag to select it and hit Control-C to copy it. And then right above my add force line here, I'm going to hit enter one more time and paste. And then I'll change this true to a false so that we're now setting it to no longer be kinematic and then adding force in our direction times a number 5. Let's try that again. Go back into Unity, we hit play. Drag our bird, release him, and well, he falls down. So the is kinematic change is happening, but the force is not working. He's not flying. He's definitely not going far enough. Let's stop playing, go back into our code, and let's try cranking that number up. Let's add 2 zeros to it. Let's make it 500. Save that off, and then go back to Unity again. And remember, it's Control-S to save. I use that hotkey constantly, so just get used to it. We'll go back into Unity now. We'll hit play again. Drag this bird. Oh, look at that. He is now flying away. We now have a bird that somewhat works. I'm going to drag him over here to the right and see if he launches back. That he launches towards his start position. Dragged him into the ground and he kind of went falling. Let's move him around real quick. I'm going to click the bird. I've stopped playing. And I'm just going to go back into grid snapping mode and just put him up here somewhere up to the left. It was negative 7.5 and 1 right now is the value that he's at. Hit play, and I want to give him a quick drag and launch him, and I think that's looking much better.